Verify that x equals 0 is a critical number of f of x is equal to the cube root x. And the follow-up question, does f of x have a relative minimum or a maximum at x equals 0? So step number 1 is to rewrite your function to make it a little bit easier to find the derivative as x to the 1/3 power. Now apply the power rule to this thing. F prime of x is equal to 1/3 x to the negative 2/3. All right, and then I want to rewrite it with a positive exponent, so this will be 1/3x to the 2/3 power. All right, and then it wants us to verify that x equals 0 is a critical number. What's it mean to be a critical number again? Critical number means that f prime of c is equal to 0, or f prime of c does not exist. Okay, so if I were to find plug in 0 in this case, I have 1/3 times 0 to the 2/3 power, which does not exist, is undefined. So what is happening at that particular point? So we just found the derivative. Derivative is supposed to give us slope. If I take 1 divided by 0, this is going to shoot off to either a positive or a negative infinity. In this case, it's going to be positive because we're squaring our number, which indicates a vertical tangent line here. Do you have yourself a relative minimum or a maximum at that particular point? Well, think about what the graph of the cube root of x looks like. It's the inverse of the cubic function. It looks sort of like this. Brip, right? And then right here is where we're talking about specifically, right here at the origin. And you can see as I move closer to the origin, it's getting steeper, 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 steeper to infinity. And then it's, it gets a lot more horizontal as I move towards the right. So I do not have a relative minimum or a maximum at that particular point. So what this means is if we go back and talk about Fermat's theorem about relative extrema only happening at critical numbers, the question was, could I just take this and flip it around? If you have a critical number, are you guaranteed that it is a relative minimum or relative maximum? Well, this example clearly shows that it's not the case. So in example 4, it's asking us to write the converse and the contrapositive of this statement, which is, again, Fermat's theorem. So let me come down here so I have some place to write. So if you have forgotten from geometry, converse goes like this. So we're assuming that we're starting with a P implies Q kind of statement, and then the converse is just the reverse of that. It's Q implies P. So in this particular case, if F has a relative minimum or maximum at x equals C, then C is a critical number of f of x. The converse of that would be starting with a critical number. If C is a critical number of f, then f of x has a relative minimum or a maximum at x equals C. Is that true or false? In this case, it is false, and a counterexample would be the one that we just worked on right here in example 3. Okay. The next one, how about contrapositive? How do you write the contrapositive? Contrapositive, you flip them and you negate it. So it's not Q implies not P. So in this case, it would be if C is not a critical number of F, then F does not have a relative minimum or maximum at x equals C. Is that true or is that false? That one is going to be true, because remember that this is always logically equivalent. Logically, it looks like trash. Logically equivalent to the original function, to P implies Q. If this one is true, which it is, then its contrapositive must be true. So if your function does not have a critical number at x equals C, you can't be a relative minimum or a maximum. And then once again, the original statement, if your function has a relative minimum or maximum at that particular point, then the value of the derivative must be either 0 there or undefined.